Hi, I'm Tom, welcome back to another PlayStation 2 programming livestream. Today we're doing more work on the little side-scroller I've been working on. Nothing too glamorous yet. We're still building up towards 3D. It's been a long, slow path there, but it's slowly coming together. Let's show off what we have so far. This is running in the emulator PCSX2, something resembling a little side-scrolling platform. We've got a little character, we can jump on things. This is a wonderful tile set that I found on itch.io, which I'll credit in the repository. And, you know, it's nice having a little box room to move around in, but it would be really, really nice if we could load extra levels. And so that's what we're going to start to do today. We're going to start building the machinery we need to manage game resources and load different things. X-Links, hello, welcome to everyone coming in. So I did a bit of off-camera work in the last probably 10 minutes, okay? And so instead of doing all of our tile map setup in the main function, we now do it in a file in our source levels folder. All right, so this is everything we were doing before. We initialize the tile map, we place everything down, we set our walls, we set our floor. This is good. This is a good change. And so we just call, you know, init this level when we start the game. Nice. What if we wanted to load another level, right? We could write another init function like this. It could take the game context, it could clear the tile maps, it could put everything in. But what if we wanted to show these levels side by side? What if we wanted them to exist at the same time? We would need a slightly different abstraction, right? And that's what I kind of want to start to move towards. This is my first goal today. Make this a slightly smarter thing. So add a little bit of extra structure to the game context. And I think the best way that we can do that is to maybe have another struct called level context. And the game context is gonna have, two of these, okay? So, what does the level context have in it? Well, it might just, we want to load some arbitrary data when we load a level, right? So it's going to need some kind of just generic heap that we can chuck stuff in. And this is the approach I learned from Quake 3 when looking at how Quake 3 works. When it loads a level, it just kind of has a heap that it fills up with garbage. And then when it loads another level, it throws that heap away. We're going to do that same thing. We're going to have two levels, so we can load a second level, you know, fill up that heap, and we'll just have two generic buffers that are only local to that level. This means, this is going to apply to VRAM management as well. Each level is going to have its own start of VRAM point, so they can both fill up a certain subset of VRAM at a time. That's the goal. So our level here, now instead of the entire game having a tile map and a collision map, each level context will potentially have its own tile map and collision map. The camera's global. We're going to just have some generic heap. We'll have a size t heap size. And this will be, you know, this will get allocated once and then overwritten and overwritten and overwritten. This is a bit like a bump allocator. It's actually exactly a bump allocator. We're just going to have two of them because it makes swapping easier. We need a unsigned int level target. This is the level, maybe we'll say active level, right? The level that we're currently kind of in, the one that we don't want to override when we load the next thing. And then we'll kind of swap between them. Beautiful. So, there's another thing we're going to need, and that is going to be, and let's put it in here, let's make a type def, and I'm going to look this up because I have to look it up every single time, c type def function pointer. I think, I'm going to take a guess at the syntax. I think we want to say init level, and it should take a struct game ctx, and a struct level ctx. I think this is the syntax. I think this gives us a type called, and we'll call it maybe level init fn. I think this is how we do it. Let's double check. Type def of a function pointer in C. Yes, this is in fact the right syntax. Awesome. So the goal is we'll be able to say, you know, ctx load level, we'll take a level init function, and we'll take the game context that we're dealing with. And then I guess we probably also want to say ctx swap level. Maybe we'll call this swap active level. And this will be a little bit manual in how we deal with it, but this will be good. Let's add another thing as well. Let's add another type. We'll call it level update function. And yeah, this is good. This is good. This will take, yeah, the game context, I guess the level context as well, in case we want to look at anything in the heap, and a float dt, and that's it. Cool, and so this will have a level update, fn, we'll just call it update. It doesn't get to draw anything, it just gets to update. This saves us making garbage one-off entities. We can just write functions instead, which is cool. I think that's nice. I think that's nice. Okay, so our context just got a lot more complicated. This is going to have a lot of knock-on effects. A lot of things are going to break when we do this. So let's go and let's make our level loader into this type, right? This is now the type of the thing that this init function needs to be. So it takes a game context. It also needs to take a level ctx. We'll call it LVL. This is the thing we're loading into. So instead of initializing it here, we'll now say this. Now tiles.h, tiles.c, I think, do we allocate when we init? We allocate here. So we don't actually want to allocate here, right? This isn't quite what we want. Except it kind of is as well, because we might need to, we're gonna need, See, we need this to be an arbitrary size. So we actually want to allocate this from somewhere else. We don't want to calloc it. We want to allocate this buffer from, the buffer for these tiles. We want to allocate this from this heap. So when we say tiles init, I guess, do we pass in a function that allocates? Like a calloc-like function? That's probably the right way to do it, isn't it? That's probably the smarter way to do it. Or some kind of allocator type. We'll make source alloc.h, why not? If and def, what am I doing? I just define. And if define, spelling is, it continues to be hard. We'll call this, it's going to give back a void pointer. We're going to call it alloc. We'll call it alloc fn, I guess. fn underscore alloc, alloc underscore fn underscore t. Apparently the underscore t thing is reserved by POSIX. You're not meant to name type something underscore t in C. I don't know if that's fake or not. Size t, num, size t, size, I guess, right? The number of things and then the size that we want them. We want it to be calloc-like, not malloc-like, for very silly reasons. Okay, and then, but how do we can't make a function that wraps that up, can we? So actually we probably want this to take some kind of allocator. Or like this. This is the other thing you can do with it, right? I remember the typedef function pointer syntax without looking it up. Do I still have the tab open? I do. I already looked it up before you got here. I'm quick. You got to get in quick to catch me looking up the typedef function pointer. First thing I do every stream. Do we do it like this? Do we take this awkward self pointer? I guess maybe we do. And then we have like a weird awkward bump allocator that does stuff. I don't know, is this right? Is this how I do it? Probably. So we make this weird gross allocator that has like a thing, and then we can make a function which fits this shape that just takes a void pointer that we then cast. I guess that's how we do this in C, right? I'm sure there's a smarter way to do it in C, but we'll do it like this. Except how does that get passed through? How does that get threaded through if I pass this as a function pointer? Hold on. I guess the thing we actually want is, let's call it allocator T, because I just said we're not going to do that. I guess it's got to have void state and then an alloc function, right? I guess it's got to be like this, because then the function takes the state from here, and this state is going to be a size and a pointer. This is kind of disgusting. I kind of hate this, but that's okay. That's okay. Let's go with this. Let's roll with this. This is solvable. I hate it, but it's solvable. So then we want to have a function that's like new bump allocator. Oh no. Oh no. Let's just put this in context dot h dot c. We'll say level ctx level. So allocate against a level, size t, num size t size. Okay, we're getting there. We're getting there. Right. So when we allocate from a level, is C going to complain that this isn't a void pointer? Do I need to do this cast, or will C just mangle this for me? Let's assume C is going to be permissive with what pointers it accepts, because that's usually the C MO. So level alloc. So when we allocate something from a level, we want to say level. We want to say size t total is num times size if the heap pointer. Oh, we also need to know where we are in it. So let's say size t heap head. If this is bigger than the total heap size, then we have a problem. We need to say log level heap overflow, and we want to return null because we didn't allocate anything. Super Cricket, good evening. Welcome. How's it going? Have you played any CPMA today, Cricket? Seems to be the done thing this week. So, otherwise we remember where the head is. We say level heap plus level heap head. You spent the night watching Matrix 4. Have you seen Matrix 4 before? I haven't seen it yet. One of my friends saw it. He said it was disappointing, and so I just haven't bothered. I don't watch enough movies to really to fuck with that energy. Cool. Okay. So this is how we allocate stuff. This is how we allocate stuff within a level. Excellent. Excellent. Now, the other funny thing is we probably want to have an allocator in here. And I'm going to rename my allocator to not be allocator underscore t because that's a silly name. I don't like it. I was only messing around with that. So we're going to have an allocator in here. And the funniest thing about this is this allocator's state is going to point to the overall level context. That's how we're going to do this. That's how we're going to do this. Cool. Okay, so. And then we call level alloc with... Wait, the allocator function should... Hold on. I missed a level here. Cannot seem to form an opinion about it. That doesn't bode well. I want to either love a movie or I want to hate a movie. I don't want a middling movie. I'm happy to watch a movie that I hate. A boring movie is basically the worst thing. I've missed a step here. I'm still missing something with how this should be called, right? Because if I'm in here, okay, I want to be able to basically pass level allocator to this as a pointer. Actually, not even necessarily as a pointer, but let's do it as a pointer just for fun. And basically say we're going to make an allocation, but I want to make it against this allocator. So how do we use an allocator? So if we're in tiles.c and we say tile map init takes struct, we can do this on a new line because the line's getting too long, struct allocator A. We want to say allocator alloc. Alloc from A1 width times height. We want to say something like this, right? This feels too complicated, but let's do this. And I think this works. I think this works because I guess we could also call that, yeah, so this is just shorthand for saying a alloc fn a state 1 width times height. So the reason this function exists, the thing that's catching me up here is the fact that this function exists at all, but this is nicer than having to write this and know about the fields inside. So I like this. I like this. Tm tiles equals alloc from. So we need to include alloc.h. We need to make source alloc.c. We need to include alloc.h. We return a alloc fn a state num size. Okay, now if I make this, it's going to yell at me for a bunch of reasons. It's going to yell at me for so many reasons. I should have done this in smaller chunks, but that's okay. That's okay. The funny thing is, right, with this allocator, we could actually pass it by value because both of the fields are pointers and they shouldn't change. So we could pass this by value. That might be more efficient, but we're not going to do it right now. So this tile map now has memory. Right, we now allocate the memory for this tile map. It points to the levels heap, which is good, which is really good. We love this. And we should zero it as well. It should be zeroed. Actually, and maybe that can be a job of alloc from. Let's say void out num times size. Let's say mem set out 0 total. I think this is the order. Again, have to Google it every time, and that's fine. There's nothing wrong with this. There's nothing wrong with this. SCN, that is exactly what I did. And does it return pointer to the memory area? S, so we can just return it. Beautiful. Cricket, I watched Alien Resurrection for essentially the first time the other day. I figured that's your kind of movie. I figured that's kind of your domain. It was an experience. I also struggle to form an opinion about Alien Resurrection, but probably for very different reasons to The Matrix. For at least Alien Resurrection, I was entertained. I was consistently entertained from the start of the movie to the end. I don't think it's not a good movie, but it was a very strange and entertaining movie. Proto Firefly. In many ways. In many ways. Okay. So that zeros, which is a nice little bonus. We manually set some stuff. This is cool. I think this is good. I think this is good. We also we probably want to say level context update is 0 because we'll check if this is null. And if it's not null, we'll run it. Now we need to initialize these level contexts, which we can do. So let's make a new function. Let's call it int ctx init. Wait, is sequel subtitled Resurrect? Is Matrix 4 subtitled? Resurrections. Huh, I forgot that. I completely forgot that. That wasn't the link in my brain. The link in my brain was Fourth Movies, but that's actually a weird intersection between those two franchises, having a fourth movie named Resurrection. I really didn't expect that when I started speaking just before, but there we go. There we go. Okay, so CTX level. Can I initialize like this? Probably. Struct. I don't even need the type name. I just use braces. I can. This should be fine, right? And I just want to say the dot heap equals malloc or even calloc 1 times level heap size. Let's give them let's give him 2 megs, which is freaking not that much in PlayStation 2 terms, but also quite a lot. And we'll do this for both of them. I think that initialization is legal. I think that's fine. Oh, and the dot allocator. So we'll say void heap equals calloc 1 level heap size. We also need to initialize the allocator, which is going to be a nested thing. So the heap is the heap. The heap head is 0. The heap size is level heap size. The allocator is state equals a pointer to the thing we're currently initializing, which is really funny. And alloc fn equals, and this is where we need to actually write our bump allocator function, because we don't currently have it. So we're going to go static void level bump alloc. Wait, oh no, I wrote this. I did write this, didn't I? It's down the bottom here. Level alloc. We're going to make it static. We're going to move it up the top. Okay, here we go. Also, define doesn't have an equal sign in it. The allocator function is level alloc. Beautiful. Okay, this probably isn't legal for some bizarre reason that I haven't worked out yet, but that's okay. That's okay. I like that this thing, while we're initializing it, we make a pointer nested within it that points back to the thing we're initializing. That's kind of like some real bizarre C stuff. I'm going to run to the bathroom really quickly, and I'll be back shortly. Just a sec. All right, we are back. So the question on my mind is, will this work? Will this work? Let's also, sorry, very importantly here, let's just return 0. There's no way this can fail, right? I mean, if this returns null, so let's maybe check that. If not heap, then we want to say log ctx init allocating level heap failed, level I heap failed. We'll return -1 because something went wrong. Excellent. So this, now all of this is going to break as well, right? Because entities is fine, but is free point. It's no longer CTX collision. It's now going to be contact. It's now going to be CTX levels, CTX active level dot collision. Levels active level dot collision. Nice. Now this is going to be the same thing, right? Except let's draw everything. I think that's probably better. So we'll do 2. We'll say draw tile map CTX levels 0 dot decorations and CTX levels 1 dot decoration. We'll draw on both. Cool. And actually, maybe let's test both things here as well. Otherwise, it's going to get tricky. If not, this and actually, let's copy this first and not this. Cool. Cool. Okay, good. Nice. Decoration width, decoration height. I think we're good. So what happens when I build this right now? Naturally, a bunch of errors. Size T not defined. That's very easy to fix. That's the level of error I'm hoping I have to fix right now. Make source. Cool. Okay, struct allocator declared inside a parameter list. That's because this has to come first. This has to come first. That's going to fix a bunch of stuff. Alloc fn. Struct allocator has no... Ah yes, of course. The type's called alloc fn, the function's called alloc, obviously. Memset, we need to include string.h. Should have seen that one coming. Tilemapper init has a conflicting type, because in tiles.h we need to now include alloc.h. Maybe it should be allocator.h. And we just need to tell it that we're also taking a struct allocator a. Okay, well that's a step closer. That's a straight step closer. Level context, defined inside a thingo. Let's just put it... now. Because this struct references this thing, what we actually probably need to do is forward declare these, which is really silly, but that's okay. Level, CTX. Then we actually need to move these back up to the top. Oops. And now it should work. It knows that there's a struct called game context and level context. It doesn't know what's in them, but it knows they exist, and it's just taking pointers, so that's legal. Level CTX. Yep, let's define you first. Actually, wait, that should be fine, because again... No, but in this case, it's not a point... Actually, it is. It's well, because it's an array, not a pointer. So this needs to be defined first, which is very silly, but it's okay. We'll survive. Okay, nice. Nice. Struct allocator does not declare anything. That, however, does. Game context has no thing called decoration. Okay, now here, instead of passing the game context, we actually want to pass the level context. And we'll just call it CTX because that's easier. Level context. Level CTX. My apologies. That's better. Struct game context has no. So we want to change this to be the level. We're going to set all the background stuff. Level decoration. Okay, now I think we're good. This should be the level. Okay, we're closing in. We're honing in. What else you got? What else you got? Static declaration follows non-static declaration. That's fine. Total statement with no effect. Yes, true. True. I somehow missed an equals in there. That's okay. Expected expression before token. Okay. So are we not allowed... Are we not allowed to do this? See, brace initialize array. Is this illegal? Yeah, I mean, there's not arrays. That seems to suggest that this would in fact work. Expected expression before. So it looks like this maybe does not work. That's okay. This needs a semicolon. Yeah, it's just this thing. That's okay. Okay, so we can do this. So we just say dot. Everything that had a dot before just becomes this, and all of my commas become semicolons. Comma, semicolon. Cool. And then we grab YT dot. We put that here. This is a bit more complicated. So we're gonna say dot allocator dot state equals this. I'm gonna say alloc equals level alloc. Cool, that was a pretty clean refactor actually. I thought that was gonna be more awkward. This is okay. Yeah, okay, so it can't, C can't deal with this incompatibility. Now, can I just brute force say that, in fact, I guarantee this is an alloc function? I really, really promise you, and you can. So, even though C says the first parameter of this should be a void pointer, if I'm just like, nah, I promise you this is a void pointer, I can not do that cast manually. That should work, you think? I also think, I don't know, maybe, hold on. The other thing actually is that maybe in the make file, I should just say, is it dash, is it C11? STD. GN, I think just C11 should be fine. Okay, so this is going to blow up for a couple of reasons, which is probably funny. And also maybe not funny. Let's just undo this and see if manually saying that we're using a newer C standard actually magically works. Nah, still doesn't like it. Weird. Okay, so excellent. Level bump allocator. Let's just dump all of our current state every time we do an allocation, because that's going to help us out a bunch. Size equals ZU. And maybe let's even log the pointer as well. PTR P. P format specifier for pointer, which is always very fun. Level heap. Level heap head total level heap. Beautiful. Okay. Yeah, let's make run. What do we get? A bunch of stuff. Bind buffer, and then it yells at me and it blows up, which is cool. Oh yeah, that's actually really easy and obvious. That's really easy and obvious. Because here in main, right, we initialize, I mean, for one thing, we're calling level a test initialize whatever, but we're calling it with the wrong arguments. For some reason, we've not triggered a remake of this file. So if I make C source clean and then try and remake it, it's going to yell at me with errors. Because, I mean, for one thing, this variable's unused, which is funny. Has jump buffer, because we're using has jump buffer now instead. So let's do that. Yeah. That's good. No member named collision. Dot grid size. Okay, so we've now given each level the power to define its own tile size, but really that should not be allowed. So let's go back, let's go into our level, right? And where we pass this in, where we pass this size thing in. And let's just define this as a constant, okay? Let's say grid size let's say grid size. Beautiful. And we'll include like that, I guess. Game context. We need to include game context.h. This should be game context because we went inside a folder. Conflicting types for level test entry init. Test entry, oh yeah, of course, because I haven't updated this yet. Okay, so now let's do another make C clean, and we'll do another make. And we're getting closer, Okay, collision grid size. So instead of this, we're just gonna say grid size. This is just a constant now, grid size. It cannot change, that is illegal for it to change. Grid size. Could have done a better find and replace here, but that's okay. I didn't realize it was going to be this many times. If I looked at my quick fix list more carefully, I would have known that, but that's okay. Now let's include levels.h. Okay, now we're getting somewhere. Now it says we can't actually call this function, right? Because we don't have enough stuff. And this tells us a few things. First, we need to call context init, ctx, and then, oh my gosh, we have a spammer. We got a spammer. Let me just... Online casinos. Wow. It's incredible. These spammers are just so strange. Real unusual stuff. Really unusual stuff. Okay, context.c. There's another function that I wrote the header for, but I haven't implemented yet, and that is load level. Context load level. Let's put that down the bottom. Why not? Context load level. Okay, so what we need to do for this is we want to get whatever the active level is not. So we're going to say unsigned int target index. This is going to be our context active level plus 1. Oops. Modulo we're just going to define this for now as 2. Like, it's a little bit jank, right? Level max. It's not actually flexible in the type yet. It's hard-coded as an array of size 2, and we've done some hard coding here as well, but we'll put this in here just for fun. We'll say struct level context level ctx x. It's going to be the game context levels target index, and then we call the function with our context and our level context, and we return that. Beautiful. And then the other function we need is swap active level, and this is going to be the same thing. All we do is say ctx active level equals target index, the last thing we loaded into, or the next thing we loaded into, I guess. And this is why we only have 2, really, because we're doing a swap. That's all we're doing. Okay, so struct level context. Yes, this needs to be a pointer. Good. Control reaches end, a function, return 0. This is my answer to that every single time. Too few arguments to function. That's okay, because all we're going to do now is call ctx load level. We pass in our context, and we pass in, this is a function pointer now, level test entry in it. And we want to then say context swap active level. And we call this because then the next thing we load goes into the alternate buffer. Nice. Okay, so if I run this, without cleaning first, so we don't have to rebuild everything. It should give us the level, and that's really close. That's really, really close to working, so that's good. Let me rerun that without the terminal spam. Put tile, we love to print. We love to print put tile. We're putting tiles. That is good. Level, test entry.c. I don't know if we need to log every time we put a tile anymore. I think we've grown beyond that. Okay, this is good, this is good. Focus X, new focus box, blah, 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 all this stuff, dual shock, and itchy-s, no frame buffer. We're not trace logging, so this is critically important. Critically important. Also, hold on, player.c. Let me just double check my logic here. Now, interestingly, when we initialize our context, we're basically going to have, because we're not touching in the level, we're not touching the tile maps, we're probably going to just have garbage in there. So we probably levels I dot, let's actually tile init this thing. So let's call tile map init. Tile map init. Levels collision. Okay. And let's initialize a tile map that is 0 by 0. Except let's do it down here. 0 by 0. With a grid size of grid size. Offset of 0 and 0. And an allocator of this thing. Except we can actually probably just pass in a null allocator. I guess we're still going to try and call the function. Okay, what if I don't actually call init? What if I just say collision and I just hard code the width and the height to 0, right? That should be okay. Because then we shouldn't actually do anything. We should always say, but hitting something outside the tile map. So we need to change what this means. Tile invalid. What we actually want to do now is say that hitting something outside the tile map is actually no hit at all. That's the goal. That's actually what we want to do. Because we might have 2 tile maps loaded at once, and just because you're outside the bounds of 1 doesn't mean you're hitting anything. Levels I collision width height. Okay. So basically we're saying tile map tm tile map init. Wait, did I break tile map init when I was clicking around in this function? What did I do? How did I break this? Struct tile map. Struct tile map. Tile map. Blah, blah, blah. Tile map init. TM undeclared. TM just has a forward declaration. Struct tile map. Tile map. alloc.h. Tile map. Tile map. What the hell? I'm going to do a clean rebuild again, because I think... What the hell? TM just has a forward declaration. In the source file, tilemap init. Int, allocator. Int. Why is it saying this is not... Huh? This is the same type. This is legal. This is valid. Unless I've broken this some other way. Like what? Why are you suddenly... Tiles? Alloc. Alloc.h. There's no like loop here. What? What have I done? What have I done? Get tile set. A broken C. I've broken C. How did I do? What did I even do just now? This is why you don't do such gigantic commits. I have no rollback path. Except it shouldn't, because tiles, tiles.h, tiles.h. All I did was, what? TM is undefined. What have I done? Am I blind? Have I missed something really obvious? Tile map init, tile map TM. Semicolon. Semicolon? Which semi... I can't see where I've missed... It's missing semicolon makes sense. Tile map. Oh, I changed a semicolon. Thank you. Thank you. I was going really crazy there. Okay, there we go. There we go. This is why I have chat here, right? I need people to do my homework for me. No, to help me not make really stupid mistakes. So tile invalid is really valid when you're drawing, but not so valid when we're colliding. So what we actually want to say is in context, context is point free. What we want to do, get tile world. So we want to say if get tile world equals, let's say car, get, it's going to be this thing. And then we're going to do the same thing for 0, 1. So we want to say if t0 not equal to 0 and t0 not equal to 1, negative tile invalid. So we hit a point if it's not 0 and it's not invalid and no wait. Let's just say t0 not equal to 0 and t1 not equal to 0. Let's do that for now. Wait, hold on. So if the point is free if t0 equals 0 and t0 or t0 equals tile invalid, and sometimes you have to write the affirmative case first. T1 equals 0 or T1 equals tile invalid. So if both of these things are true, right? Either it's free or it's not outside the tile map, then the point is free. Yes, okay, so that's actually, and we're testing if the point is free, so we return this. Okay, there we go. That's easier, that's so much easier to see when I put them in variables. And I accidentally undid the fix. Or I applied the same weird, that must have been a find and replace that I just had floating around. Okay, so this should work now, and it does. So we have our loaded level, and life is good. And now let's see if we can load a second level. That'd be cool, right? Now the other thing is context.c. Okay. When we update, we probably want to say, where are we? When we update, we only we do it like this. Okay, so let's not update. Let's not call update for now. MadFlash19, it's PS2, so I'm using PCSX2. It's not really an alternative, right? It's PCSX2 or it's bust. I'm a PCSX2 purist. Fight me. Aether PSX, whatever they're called for Android, right? I don't know. I don't think there's much of an alternative. PCSX2, all the way. Okay, so this level loading is good. Let's see if we can load a second level adjacent to the first level while the game is still running. That would be good. The goal eventually is to juggle VRAM with this as well. That would be really cool, so that we could have different VRAM strategies and draw stuff in fun ways, but we'll get there. We'll get there. So let's add another level. Let's copy what we have. Copy source levels, test entry. Let's go to source levels, test adjacent. Oops. Cool. We'll keep these set walls and set floors, and we'll call this level test edge init. Okay, update we'll set to a null. We'll do this, except now we'll move these things to some offset. So we'll put them at, now they're 40 pixels wide. So let's put this at, hold on, let's put this at 640, one screen width. Let's put it at 660. Let's not align it nicely to the grid. Let's leave a little gap. And let's draw the same thing again. Okay, cool. So, level test edge init. And we'll go into main. Init. There's so many things called init in here. After we swap level test edge init. Okay, so we should have loaded another thing next to this, and it looks like we've got a copy. So we're gonna have to tear down these walls in order to get across. And it looks like we have a gap too, which is really, really nice. We're gonna find out if the collision handles world offset. This is untested. Also, JerryT333, thank you so much for following. I missed that, thank you. I've got my little thing, my little stream display that's meant to go over there. I did some more work on it today. It's coming together. It's very close to being production ready. Okay. So that appears to work. We just need to go into level, test entry. We need to make a little gap. So we want to say set wall. When we do the set wall, let's only put it on the left. And let's go into edge. And when we do our set wall, let's only put it on the right. Beautiful. Okay, so we should be able to jump across, and hopefully we hit the ground, and we do, and it looks like we can have lots of little adjacent rooms. So then the goal is, okay, we can load one. The goal is to unload this first room, and then load an additional room next to it, and then we have infinite scrolling, right? Maybe not. But that would be cool. That's a fun idea. That would be nice. That would be really nice. And it would be cool if we could load these tile maps from disk. That would be really beneficial as well, I think. But anyway, this is cool. This is cool. We can move around. We can jump. We can do stuff. I like this a lot. I like this a lot. It feels pretty good. It'll be nice to put something cohesive together and release it to the PS2 world. Nice. Okay. So what now? What next? And then I can also fall to my death for it. Or not. Okay, well that's not right. I should be able to fall through the ground here. I don't know what I'm hitting here, right? What am I bumping into? Adrian Codes Epic, thank you so much. Thank you so much. I appreciate the encouragement, right? It's wonderful. Let's move this over. Let's move it to 860 and see if we can put a bigger gap here. Also, let's put a little Y offset as well, just for fun. Let's move it down a little. Oops. A::. Okay. And I really like that this doesn't have to be grid aligned. I can have these grids and I can put them anywhere. It's kind of cool. Okay, so this is a big gap. We shouldn't be able to bridge this. So if I try and jump across, we get this little thing again, this weird height issue. So maybe height offsets aren't quite working properly. Oh, actually, we do have to be grid aligned. We do have to be grid aligned. I also think we started going to space there because of maybe clipping, basically. So these do have to be grid aligned, otherwise we're going to get that weird hopping behavior. because we snap to multiples of 16 when we resolve a collision. So if we're not standing in a multiple of 16, then we've got a problem. Can I make this? I can. And then we don't have that weird popping. So that's good. That's good. And I must have just by fluke. Yeah, so this isn't a multiple of 16, so we get this problem. So the first one the first offset I picked must have just by chance been either a multiple of 16 or close enough that we didn't notice. So, okay, our world offset has to be a multiple of 16. 860. I can't do that in my head. Python 860 mod 16. Oops, mod 16. 12. So it'll be 872. And now I won't be able to make the jump. Let's just set it to 656. Let's see if one little gap should be enough to fall through, right? Like it's kind of weird that I couldn't fall through the floor there. So I should be able to fall through this. And for some reason I can't. How big does the gap have to be before I can fall through it? This is also an interesting question. So what if I move it over? So this is, what if I say 15 times 16? It's a very manual way of testing this, but oh, well, that's not right. Hold on. Oh, oops. What I meant was 40 plus 10. Let's write it like this. Because it's 40 tiles across the whole thing, and then I want to add a bit more. My mistake. Bad maths, bad numbers. 10 times 16 is in fact not 640. So this, of course, is a big enough gap, right? Beautiful. But maybe let's try 3. I'm just not sure why we couldn't fall through a small gap there. Because it's kind of a problem, right? If I want to make some kind of platform-ish game, because I fall off of this at the expected point, right? I can fall here. I can fall here. But can I fall here? Okay, I think I see the problem. I think I see the problem here. I think our offsets somehow don't line up. Okay, look at this. Look at this. Ready? We're offset by, I think, 2. That looks like about 2 things, 2 tiles. Decoration collision. It looks like we're passing all the same stuff. So why would our collision be offset by 2 tiles? Is this, we're rendering off by 2 tiles? Because it looks like the rendering is correct. It looks like the collision is not correct. Can I... But it looks like it's only... These are fine. Is it offset on the other side of the platform? This is a good point. Okay, let me get rid of the other wall. Let me get rid of all the walls. Let's see what happens. So I can fall through the floor, but there's this little overhanging bit that isn't real. Do I fall through the floor early over here? No. No, I do not. That's... I don't know if that's better or worse. And that's the whole floor. That is, in fact, the entire floor. Huh? Okay, that's very strange. That's very strange. But if I set this to 4, does it change? Does it change how much of an offset there is? Or is it always just some ghost blocks? Maybe they're on this as well. Hold on. This is the other thing. Is it possible that set floor... Well, here's the better thing to test, okay? Levels, test, oops, not the object file. Levels, test entry. Let's get rid of this wall. Let's see if it's on this side as well. This may not actually be an offset thing. So is there a little weird gap here? Yes. Okay, well that's good news. That's an easier thing to resolve. I don't know why it's there, but that's easier to deal with. Cool. Okay. Okay. I don't know if I'm going to fix that right now. Maybe I should. Maybe if I want to be really thorough, I should. I'm just excited to have levels. I'm going to make this level... I'm going to make both levels a little bit longer. Just for some fun testing purposes, let's make you 80. And let's make this whole floor go the whole way across. And let's go into edge. Let's make you 80 as well. 80. And make this floor go the whole way across. And 80. And you're just going to be offset by the width of the previous level. And this is going to fill the whole background, which is cool. Okay, now, we do have this little slight problem. Which is, if we try and draw things from too far off screen, they look like this, okay? This will also happen if we fall off the edge of things. These are tiles from far, far away. And you'll see, right, as we get further over this way, so we're in the middle, nothing's weird. But as I get close to this edge, the tiles from the far left side, they're going to start getting funky. Because the graphics synthesizer can't deal with this kind of clipping, and if I fall down, the vertical tiles are going to start doing this as well. Cool. So, yeah, and this is because... And I guess we wrapped around. Because again, the graphics synthesizer is dumb. It doesn't understand off-screen. All it knows is we give it some numbers, and at some point, because they're fixed point numbers, at some point they're going to roll around, they're going to come back on screen again. So what we need to do when we draw in our context, we need to do a check against the camera, right? And let's actually do it in draw tile map, maybe. Maybe we do it here. I think this probably makes more sense. So we want to say, so if this tile map is not in the box of the camera at all, okay? So, and how do we do this? We say if cam.x is less than tm world offset x, if the right edge of the camera is less than our left edge, so this is cam x, I need to remind myself, position 0. And maybe this should be a function in camera. Maybe we're going to write this more. If camera contains, so if this area is inside the camera, tm x, tm y, tm width, tm width, tm height. So if this tile map is not inside the camera at all, don't draw it, just skip it, and then we won't deal with that kind of weird artifact. So then we need to write this function. So let's say int camera contains area, float x, float y, float width, float height. And it needs to take a camera as well. My mistake. Struct cool. I did not pass the camera in as a pointer here. Okay, so camera.c. So if x plus w is less than our camera's position 0. So if the right edge of this box is less than the left edge of our camera, it's out of the bounds, it's out of the range, right? Or the x, the left edge of our camera, is greater than the right edge, right? So this, I should be drawing more. I should be drawing more. If this, oops, let's not drag this around. If, oh, very small pen today. If this is the area of our tile map, right? If our camera is over here, the X position of the camera is going to be greater than the X plus width of the tile map. This is X plus, this point here, kind of, this line here is X plus W. So if the X is outside of it and the Y is outside of it, Y plus height, and just Y, and then we change the zeros into ones, and that's it. We return this. So the camera contains the area. It's not this, it's the inverse of this. So this means the camera is outside the area, the camera is outside the area, then we nod it. That tells us I forgot to change the scene back, that's okay. I didn't really do much. We ended up with this, The code isn't that tricky. Okay, so let's see if we can build this, and it'll probably yell at me about something. Expected, wait, where's that if, sorry? Draw.c. If. Yep, just some wrong bracketing. Struct tile map has no member named X. This is because it's called world offset X and world offset Y. Wonderful, wonderful. Wall defined not used. Also, hold on, I think the width and height are defined in terms of grid units, so this should actually be times grid size. Otherwise, we're never going to draw anything. Height times grid size. Okay, and maybe I could pre-multiply those, I don't know. That's fine. Tile size. Tile size? Apparently I already defined this somewhere. That's okay. Grid size, undeclared. Levels.h, I think, used this. And we'll share a definition so we don't have to change stuff. That's good. Statement with no effect, because there is in fact no semi. And also I need the word return. That's really funny. Rust on the brain. Rusty brain. That's what that's called. Rusty brain syndrome. Okay. Okay, we ceased drawing anything. But that's okay. Did I just land on the... Okay. We're a little bit too aggressive in our pruning. A little bit too aggressive. X plus width less than, so that shouldn't be false, right? I thought that was pretty sound, right? Because if we're not outside it, we're inside it. Now there is another box intersection algorithm that's very simple, where you do like a subtraction, right? Where you say, so let's think of it. So it's x. If this x coordinate minus this, if this x coordinate minus this x coordinate is, what if it's less? If this minus this, then it's negative. Then it's this minus this. So this minus this. If the difference is less than the width, then it's inside the thing. So let's try this one as well. So if we say x minus, right? This is for if a point, I guess, is inside of it. So let's write this. So let's say camera contains point let's try writing a different version of this. So return what is, so x minus c position. Let's think about if it's to the right. So if it's to the right, then this is simply less than c bounds 0. Right? This point is inside here, and if it's to the left, it's just not inside. Easy. Easy. Okay. And y minus c position 1 is less than c bounds 1. Right? So the x and the y are both inside this thing. It contains this point. Now, if our area is bigger, then this won't work. We can't check 4 corners if it's inside. So that's actually no good. That's actually no good. And in fact, this might be exactly what happens. This is exactly what happens. Our tile map is simply bigger, and so that doesn't work. AABB intersection. I just have to Google it, okay? Sometimes you just have to Google it. Branchless slab method. This sounds familiar. Yeah, you do this subtraction and division thing. Okay. Tmax. Hold on. Ray, no, I don't want Ray bounding box. I want AABB. No. AABB. 2D slab into. Give me this slab method. Give me some pseudocode. Oh no, Ray. Hold on. Raybox. What's the algorithm for this called? It's so simple that people don't really do it, right? Xmin Xmax box 1 for 1D and this. Why? Yeah. Oh yeah. Okay. I like that. I like that decomposition. You just do 2 one-dimensional overlaps. So that's Xmax 1, Xmax. So this is bigger than this, and this is bigger than this, because this box goes from here to here. So this is bigger than this, and yes, okay, I like this. So we can do this. So let's get rid of this. Let's forget about points. Points suck. We don't care about points. We care about boxes. Okay, boxes are interesting. Boxes are good. And we want to say Xmin Xmax. So if return. So we'll say X part. We'll do the X overlap, and that is C position 0 plus C bounds 0 greater than X, and X max 1, X max 2 greater than, and so X max 2 would be X plus W greater than or equal to. We care about equality. Greater than equal feels right. C position 0. Does that make sense? So what do we say? So what we're saying is, so if this is our camera, so this is greater than or equal to this. So you can imagine a different case where like this is inside here, which would pass. And X, this is greater than or equal to this. Yes, okay, so that's true. What about this case? C position is greater than or equal to X. This is true. And this is greater than this, which is true. Okay, yeah, so that's this overlap. That's what we're detecting. Okay, good. Yes, I like this. We can do this 0, 1 thing, and then we just change our X's into Y's and our width into a height. Good. Okay, now we can run this and it will work, because we're doing overlap properly, and we no longer get these weird artifacts, which is cool. And then once this tile map comes into view, we're going to start drawing it, and then once this tile map goes out of view, we're going to stop drawing it, and you can't tell, except now if I jump off, if I go over here and I jump off the edge into the void, we're not going to get weird Y artifacts as we fall either, because they're just going to quietly stop drawing. Okay, so we fall down and nothing. The sweet embrace of the abyss. Okay, that's actually really, really important. That's so crucial to having these longer levels. Let's add some of this stuff because, and this is going to be a really silly big commit, but we're going to say commit level buffer level double buffer level loading. We have 2 level buffers, right? So here's the thing. Here's where it gets interesting, okay? Let's add a 3rd level. We're going to copy source levels. Let's go test adge.c. We'll put it into source levels test load.c. This is really silly. Okay, we're going to have to make test adge a little bit longer. We're going to make it 100 tiles long. Gonna have to make it 100 tiles long. And oh, some of your Pico 8 code. This is just how you write Pico 8, right? This is normal. This isn't even bad code. Pico 8 just encourages you to do weird jank stuff, and I love it. I love how simple it is. Like, you don't have to have abstractions. You can just write really basic, and you kind of have to write really basic Lua, you know? So that's kind of cool. It's kind of cool. I respect it. I fuck with that style of writing code. I mean, look at how jank and simplistic all of this is. I've got abstractions, but I don't know if I should. I don't know if I should be allowed to. Okay, I'm going to do something fun over in test load. I'm going to do something fun. Now this has to be at, we need to kind of know where in the world it belongs, which is interesting, but this has to go 80 plus 100, okay? We'll make it 80 by 80, but instead of doing this, let's say, as we loop over this, let's go float h equals sine of, let's go xx times 1.f divided by divided by 10.f. So we get a couple of little bloops, little bit of math action. And I think, is it sin or is it synth? I think it's f sin, right? No? Is it synf? Synth. Synth. It's synth. It's fabs, but it's synth. Cricket, what? Link some of your Pico 8 games. Link something. Come on. That would be cool. I'll have a look. I'll look at it on stream before I finish the stream. And then the height. So this is between -1. Let's say 2.2 times h, but as an int plus 20. I might need another bracket in there. I'm being very conservative with my brackets. Very, very conservative. Actually, I should probably... Well, we can kind of BODMAS this, right? We can convert to int at the last possible step. Okay, that should work. We need to include math. We need to import math. Of course. Expected a thing before the thing. Yep, I am 1 bracket shy. Set will defined but not used. Okay, good. Test load. Let's put a wall back. Okay, so this isn't going to load anything, right? For one thing, we've got a problem. We've got a problem. Level test adge init. Yeah. So this should be level test load init. We're going to go into levels.h. Oof. Okay. So now in adge, now in our adjacency level, we need an update function. We're just going to call it update. We're going to struct. I need to remind myself what the signature looks like. Update function looks like this. Update takes a DT, takes a bunch of stuff. dt. Okay, and all we're really gonna do, we're gonna find the player, and we're gonna find the player because we know there's only one entity. So we can say g entities, entities 0, tgt, entity. We're gonna grab a reference to this. We're gonna say if our target's x coordinate is greater than, okay? So our world position is 80 times 16. So if it's greater than 80 times 16 plus 50 times 16, if it's greater than 130 times 16, in fact, then we want to load the other level. But we still want the current one, so we don't want to swap until we've like moved into it. Okay, that's okay, that's okay. We can do that, we can do that. We can do that. So let's do this the jank way for now, right? So we'll we need a clean function as well. We need a cleanup function too. Right? For when we're moving out. We're done. We're done with this level. We also need an active flag. So all these functions, when they initialize, we need to say level active is 1. Responsible boat ownership. Okay, when I need a little break, I'm gonna look at that. That sounds great. Only game you have online, it's nearly unplayable. But it does look kind of nice just from this thumbnail. I like the vibe. It's very Atari in a good way. I think it's good. I think it's cute. Test load. Level active, test, entry. Okay, cool. So free a level, and this always frees the non-active level, right? The thing in the other buffer, which is good, which is good. So when we free a level, there's a few other things too. So let's implement this. When we free a level, we need to set that flag most critically. So we're gonna say struct level ctx x is this, the off level. Okay, x active is 0, and then we say if x cleanup, we want to call x cleanup ctx x, and then we're happy. We're happy. We also want to say x heap head equals 0. We move our bump allocator back. We reset the only important state when it comes to persisting this stuff, which is just say that the heap header is back at the start of the thing. Allocator, yeah, beautiful. Maybe we do this too, actually. Maybe we do this too. This is good. So now when we draw, we probably want to say draw tile map, context draw. When we context draw, we want to say if ctx levels 0.active, then we want to draw it. Similarly, if this level 1 is active, then we draw it. Okay, now G entities. That's okay. I should be doing this inside Vim, so I get a quick fix list, struct entity, G entities, G context, game context, entities, struct entity. That's probably because I'm just not including .entity.h, game entity. Cool. Initialization of struct entity from incompatible pointer type, struct entity. Beautiful, beautiful. Truly a thing of beauty. Entity. Struct entity. Is this because I'm also including context? Surely not. Struct entity, level edge. Entity. Entity. It doesn't like entity. It doesn't like entity. What else? What other errors have I got? What other errors have I got? Invalid use of undefined type. No return statement. Update defined but not used. Set wall defined but not used. Okay, so it's all the same shit. It's all the same shit. Except we're going to give it an update function. Are we going to give it a cleanup function? Nah. Nah. Entities. Okay, so it doesn't like us trying to get an entity. It doesn't like us trying to reference the entity type, which is so strange because we've got the header. We've got the header. Even if we get rid of that, it's still entity.h. What if I do a clean? What if I do a clean build? Struct entity, struct entity. Oh, hold on. This is that spelling mistake I always make. Entity. Level I undeclared. Here we go. Here we go. Now we're cooking. Return 0. Okay, so this is what I'm saying. This is what I'm saying. If we've gone past this point, we want to load the other level. Context load level. Load. Right, so either load the left or the right level depending on how far across we've gone. Cool, 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 cool. Like if we've crossed the halfway point of our little map, we load the next level. That's awesome. And actually, if we made this narrower, we could see when that happened, but let's not do that. Let's keep the magic alive. And let's just see if we can go back and forward a bit. I did have a system like this running on top of Lua a little while ago, but this one's better. This is smarter. Okay, so load level. I feel good about this. I feel good about this. What am I missing? We have levels.h. This is good. Okay. Okay. Oh yeah, when we call load level. When we call load level, we should free the level first. So when we do this, if x active, if it's an active level, if it's being used, we say ctx free level first. Yeah, ctx. We do it like this. Cool. We set it up. It's a new level. It's a new day. CTX undeclared. CTX. It's actually G. I. Where does this come from? I undefined. Alright, yeah, sorry. It's X. Cool. Perfect, perfect. Okay, so let's see if we can do this. So we've got our first little bit, and this is good. We've got our second bit, and this is good. It's nice and smooth. So at some point, it's going to try and load another level. And maybe that worked? Maybe? I guess it did. Hello? Yeah? Okay. Maybe? Maybe? I was expecting funkier terrain, honestly. I was expecting... Let's go into load. This is it should be doing math, right? It should be oh, it's probably doing that first, maybe. Oh, that shouldn't matter though. That should be okay. I was hoping for something funkier. Let's look into something much funkier. Okay, so this bad boy is lowered down a little, and then it goes on for a long time, and then I can't tell if the other bit's loaded or not. It's not doing anything different. So I need to go into test load, and let's just put it at a different height. Let's put it at -16. So when the height changes, that should mean that we're all okay. I was gonna make the long section wavy, but I decided that that would probably be silly because I have to traverse that the most often. There's a chance it's just not loading. Yeah, okay. Oh, do you know why? It's because we're never calling the update function. Hold on. Okay, so we need a context update function as well. We need this, we need this. And we're gonna put it with context draw, because these kind of go together. They're the kind of run the game one. Now, let's do this. Let's do this for now. Focusing the camera should be part of this as well, but it's too complicated to do right now, so we're just going to roll with this. Entities, entities max, context, entities, entity max. Beautiful. Okay, now we want to say, like we do in draw, we're going to copy and paste this, in fact. If it's active and CTX levels 0 dot update, then we want to say CTX levels 0 update. CTX levels I'm gonna rewrite this because this one's too annoying. And then we take the DT as well. I. We're probably never going to have more than 2, but I'm just going to write this as a loop because I'm just going to get RSI otherwise. Okay, now in main we call context update. 1 over 30. Cool, and then this, instead of being hardcoded to 1 over 30, is DT. Beautiful. Okay, context. We don't need to take a ref to it anymore. Beautiful. Let's see if we do it. Let's see if we're cooking. Okay, I think that's worse. I think that's worse. What happened here? What happened here? Swap active level, load level. It's like we're loading into the wrong slot. Oh, we're loading into the wrong slot because of this. So if I say this, it will work. Ish. It'll work better. Or not. Maybe not. What if we load this level first? Hold on. Okay, the fact we can't swap again is a bit of a problem. But if we load this level first, it should work. We should see some stuff get loaded, which would be cool. I would like that. That would make me happy. Okay, so we have this little bit that's down here. This is going to be a bit longer. I should just add some more random garbage to make this more interesting. This little journey. And then it hits the end. Okay, good. Let's go into our player, log, debug. Some of this stuff is just a little bit too loud. It's a little bit too noisy. This feels more like a trace log. We can keep hit the ground, that's okay. Falling is a bit too noisy. Okay, so let's go into our adjacent level, the one that's in the middle, the one that has an update function, and we are gonna log, debug. Oh, we also need, we also need to not do this every single time. So let's do this. Let's say, okay, so, and let's say const int midway. This is our world position that is halfway in between the two things we care about. So if it's bigger than midway, and the last thing we saw is less than midway, then load if target x is less than midway and last x is greater than midway. So it's only when we swap from one half to the other, then do we load the level. Otherwise we're just going to spam load all the time, and that's going to be a lot of churn. It's going to be a lot of churn. So let's try this. Let's try this. Okay, we need to, this camera is also extremely noisy. That's fine, and camera debug prints at info level. So anytime I want to see the camera info, I just hit triangle on it and it prints it out. That's good, that's good. Okay, so we're gonna go through here. We're gonna do this thing. Nice, beautiful, beautiful. And then at some point we expect it to say loaded the other thing. And in fact, it did not say that. And we're just going to do this every frame for now. So we'll say the player position, we'll say midway, and we'll say last x equals, so we'll say target x, we'll say midway, and we'll say last x. Cool. Beautiful. Okay, this is going to be much more informative. And it's going to be much more informative because it's actually not running. Okay, so context levels active levels I dot update. Let's see if that works. We are in fact spamming the shit out of this. Okay, that's good, that's good. So we come through here, and hopefully we're going to load the other thing. Okay, it looks like it said something else. So it looks like the load is triggering, and we're going to find out once we get a little bit further across here. We do indeed have another thing. The ground is not wavy like I thought it would be. The sign is a little bit less pronounced. The sine wave's a little bit less pronounced, but that's okay. That was good. Okay. We just needed to confirm that the update function was in fact being called. It wasn't. Now we're in a good place. Okay. So let's go into our test load, and let's, for one thing, just like exaggerate the shit out of this because I want to see some mathematical action. Let's also go into our first level and make it shorter. We don't need this to be 80 anymore. In fact, let's make it 30. Let's make it 30. Less than level collision width. Okay. Let's do that. So now, and the annoying thing is, this has to float through everywhere. There's no, our world coordinate system is a little bit limited. So 30. And then this is okay. And then 130. So this will be 50, this should be 80 now. Midway should be 80, I believe. We'll find out in a sec. I might do this wrong. Okay, so this is gonna be smaller. That's good, that's good. Then this goes over here, that's good. And then this is nice and long, this is a nice long stretch. We load about halfway across, we load the load level, the level called load, and I wasn't paying attention, we fell off the edge. Oh, and that's fine actually. because we moved this over, but the level we're loading is not quite in the right place. And that should be fine, really. This is now at 30 plus 100, which is more than a screen of tiles worth of stuff. So that's fine, that's fine. Let's see if this works now. That was actually what I expected, which is good. So we're gonna load it here. It gets loaded. And here we go. Here's a little sine wave of platforms. That's cool. That's really cool. Okay, so that works. That works. Beautiful. Beautiful. Okay, that makes me happy. That makes me happy. So we can load levels dynamically. I should be able to come back over here and see that first thing get loaded as well. Maybe? Maybe? It'd be nice to do these from files instead of, you know, hard-coded, but that's okay. That's fine. Nice, nice. What if, just to test this out as well, what if I never load the entry level back? Can I fix this so that it always has the other level, right? This is the other thing. This is the last thing to test. Can I go this way, and then when I come back, the world has changed forever behind me, right? So I go across, I go across, I go across. Xlinks in chat says hard-coded level values are their biggest enemy. Yeah, true. But it's a really useful testing tool to start with. You know, this machinery, like I could hook this up to a Lua script, and I know I've done a lot of Lua stuff. Nice. Okay, that's good. That's what I expect to see. This is the void. This is the end of the world. It's interesting, right? Because these APIs, you could do all kinds of interesting stuff with. Like, it would be really interesting to hook this up to a Lua script, because this logic would make a lot more sense kind of in a script format. Because I was thinking about doing JSON, but then I was like, oh, I'd have to pull in a JSON parser, I'd have to do a JSON in C, and it turns out, like, Lua tables are kind of good, but you get a whole Turing-complete language with it, so you can write logic directly into your level like this, which is kind of, you know, it's kind of fun. It's a fun way to think about gameplay. And you just make sure any kind of heavier level state just goes into this, you know, it gets heap allocated. For example, these should probably be heap allocated, right? But also, there's only one instance of these levels, so it's kind of okay. Statics are also fine. It just means they take up space in the binary. So what would it, let's, proof of concept level, is this, what would you call this? Level swapping, I guess, for big open levels. So see, if you chained these together, you would need at some point to swap the inactive level buffer, unless you had 3 level buffers. Then you can kind of do it in like a, you could have 1 on and 2 off. I don't know. Anyway. You just need to make sure you load the level into the level that you aren't. Is an array, is it a struct? It is an array. Is it an array, is it a struct? It's a Lua table. Lua table, they do everything, right? They in fact do everything. Is it object-oriented class inheritance? It's also a Lua table. Literally, you know, when all you have a hammer, when all you have is a hammer. That's the programming philosophy of Lua. And it's kind of awesome. It means the language is really small, but you can still do powerful stuff with it. I don't hate it. I respect Lua. Okay, nice. So what would it look like if these were actually part of the heap? What would that look like here? How would we do that? Let's make a struct. Okay, let's just proof of concept this out. Let's call it struct LData. Can I have a, yeah, so static by default. I don't need to say static struct. This is scoped small by default. So we have a struct, and it's going to have this float last x, and it's going to have int midway point. Okay. So now this is good because we can actually kind of do this a bit better, right? Because we have this world x. So we can calculate this based on where we put the tile map. So let's say struct LData let's put it alloc from level allocator. So we're going to allocate 1, times size of struct ldata on the heap, and it's going to be the first thing on the heap, so we can always dereference it from the heap, which is good. That's good news. So in other words, when we get the heap from this level context, we can always grab some state struct from the top of it. That's good. That's good. I think that's good. I guess that's good. That makes sense to me, right? We could keep putting things in statics. Like we could make this a static and point to something that gets heap allocated. That's also an interesting option, but I think this is better. I think this is better for now. This is how I'll probably do it in reality, even though it's still jank. So we'll say ld last x is 0. And then we'll also say ld midway equals. We'll grab the collision map. We'll get the world offset tiles h, world offset x, level collision world offset x plus level collision width times grid size divided by 2. Right, the midway point of this thing. The midway point of this thing. Cool, cool. Okay, so now in update, we want to grab struct ldata ld equals struct this is very jank. This is very jank. This is a very C solution. But now instead of this, we say ld midway, instead of it being compiled in, right? Oops, ld last x equals this thing. Cool. We get rid of these constants. They're gone. They're in the bin. ld has no midway point. I'm just going to call it midway because I called it midway everywhere else. Midway undeclared. Set wall. Okay, cool. I think this is good. I think this is good. And it just, you know, puts it on the heap instead. I love it. Let me also settings, interface, graphics, OSD, not version, CPU usage, speed percentages, settings, no, inputs, yes, resolution, sure, FPS, yes, GPU usage, don't really care, don't know what indicators are, statistics, no, frame times, also a little bit too much. Okay, cool. We've got our stats back. I'm a stats guy. I want to see my stats. Cool. We didn't really notice anything chunking too much, anything chugging crazily. We've got this ghost platform problem again, but that's okay. That's a known thing. And so this is good, right? This works. This works. And now we're storing all of our data related to the level on the heap. None of this weird static stuff anymore, for better or for worse. Don't hate me for writing weird jank C code. This is the goal, right? This is what we do here. Now, like I said, the other goal, of course, is going to be putting stuff in VRAM, is going to be the VRAM allocation strategy and having levels manage their own block of VRAM. That's good. That's going to be really good. That's going to be very exciting. Once we do it, which isn't yet. We'll get there. We'll get there. VRAM management is a little bit trickier. So it'd be nice to be able to, like, I wrote a tile editor for the PlayStation 2 before, and I think that would be a fun way. I was going to do mapping in tiled, and that's also still an option. And now that I have these levels that are kind of, you know, contiguous, and in world space, tiled is actually a really great tool for that. So I could try with tiled more in the future as well. Maybe I should try doing VRAM. I should try drawing another tile set and then loading it from VRAM. That would be very good. But yeah, I don't know. I might take. I'm not sure if I should take a quick breather or if I should call it a night. Let me do a time check. 10:36. Look, I might call it a night there. I haven't slept very well the last few nights. Okay. Awesome. Well, thank you very much for everyone tuning in. I want to try and do some longer streams. I'm trying to get there. It's been a messy couple of weeks, and probably the next 2 weeks are going to be a little bit tricky as well. But It'd be good. Thanks everyone for hanging out. Oh no, hold on. I was going to check out Cricket's game. Before we finish up. For everyone watching on YouTube, I'm going to cut the VOD there. So thank you very much for tuning in. For the stream people, the party's going to kick on. We're going to watch. We're gonna look at this game. We're going to experience Cricket's the inside of Cricket's brain. Okay, so responsible boat ownership, global game jam 2017. That's a long time ago. Theme of waves, first game ever. Okay. I freaking love Pico 8. Let me desktop audio this bad boy. Boat. I died. Oh my gosh. This is really hard to control. Do I have to be 2-player? Do I die if either player dies? Oh my gosh. So do I have to control both? Am I... Oh my god. My brain is not capable of this. This is cool though. I like it. I don't know why you're so down on it. If I'm only one person, if I have to juggle 2 boats. I don't know if driving 2 boats is responsible boat ownership. I'm taking issue with the title of this. What freaking buttons do I press? Okay, let's try and not. I'm kind of like determined to. Okay, this is too hard for mere mortals to complete. My brain is not capable. You know, I can time 3 items at once in Quake, perhaps even 4, but I cannot. Hold on, I got it. I don't got it. I'm getting the hang of it. I can time Mega Health in CPMA, but I can't work this thing out. Why is this? So what's happening here, right? Is this? Oh, you're like towing someone. Ah, I get it. I didn't get it before. I get it now. You've got like a person in a tire. So they're like radially rotating around you. Okay. This is very, very hard to play. But I do love it. I love the use of the theme. I think there's a lot of potential here. I wish I made more small games like this back in 2017 or whenever I was goofing around before I was living an adult life and doing adult things. Okay. Game breaks when you get too far from the origin. Like the rotation stuff breaks. That's really cool. It's really cool. I like Pico 8. Pico 8's really fun. Thank you for sharing. I'm not going to continue to play. This is too hard. This needs a second pair of hands. But let's throw some viewers on for a nice little raid. That was fun. That was good fun. Thank you for sharing. And I invite anyone else to share other random stuff they're working on. That can be a good kind of end of stream activity. Okay. Who we got? Who's live? Who can we throw some viewers onto? I'm always happy to take requests for who to throw viewers onto, of course. Godot Gravity Gun, GNU Linux Kubernetes. That sounds very sensible. Ludum Dare. Is Ludum Dare on? I guess Ludum Dare's on. This person's doing Ludum Dare. Is that Unity? I don't necessarily want to raid a Unity streamer. Godot, much more so. Much more raidable in my opinion. We're Godot fans here. Coding, testing, and what's this? Pogo game. Godot. Here we go. We've got a Godot streamer. We're going to throw some viewers onto them. So, thank you so much everyone for tuning in. This has been a really fun stream. We're making some progress on a funny little PlayStation 2 game. Next time, hopefully going to do some VRAM stuff and make it more PlayStation 2-y. But until then, let's go share the love with another streamer. Thank you so much, and I'll see you next time.